And I think, let me see. I think maybe I will give you the sheet. It's all right, Jeff. Maybe they'll be good kids and not look at the other side. So there's a side U substitution. Yes? Did I put practice problems in here? No, it didn't. It sucked. All right, so I won't get this to you yet. So here's a very straightforward example of U substitution. This is not a direct, backwards, antiderivative kind of thing, because I have a product in my integral for one. So the product, it doesn't have to be a product in order for me to have to do some other method, but that's a huge red flag. Do we have a product rule for differentiation? Yes, we do, right? There's a product rule for derivatives. That's one of the first rules after power rule that we learned. Integrals are always trying to undo differentiation. So I would expect that a product in an integral would suck excessively bad, because I don't have a product rule for integration. It's trying to undo what differentiation did. So one thing I want to really dispel now is you can't integrate this by integrating this and then integrating that. Can you even differentiate a product? If I had x times sine x derivative, is the answer to that 1 times cosine x? If somebody wrote that, what did they do? If they said the answer to that was 1 times cosine x, what did they do?
Something wrong.
That is so true. You picked it up from my tone. But specifically,
They forgot product.
yeah, what did they do exactly? What's the derivative of x? 1. What's the derivative of sine? Cosine. Now, of course, when I first teach product rule, I got a lot of students doing this. It's an optimistic part of being a human. You're like, please, dear God, let it work like this. But we know it cannot work like that. Of course it can't, because the rate of change has contributions from each separately. They each get their own term, right? So if I can't even differentiate factors all at once, I sure as all hell can't integrate different factors all at once. Does that make sense? If I want to say it the quickest I can, integration is always worse than differentiation. Would you agree with me now surviving Calc 1?
Yeah.
Hell yeah, I would much rather have a derivative problem. You can make it as ugly as you want to. I can still work my way through it. Than an integral problem. It's always harder, because why is integration always harder? Think it backwards. Yes? And that's always harder. Okay. So, I can't just integrate this in pieces. I can't pretend like the x is in there. What tells me that this is going to be U substitution? Yes?
The function inside the cosine?
There's a function more than just x that's inside, that's stuck in another function. 90-something% of the time, the thing you're going to let U equal is the thing that's stuck. Do you understand what I just said? That doesn't work 100%. What works 100% of the time? Letting U equal the piece whose derivative is in there also. That works 100% of the time. Okay. So in this case, what am I going to let U equal here?
Like squared minus 5.
Yeah. And then what's du?
4x.
4x dx. Don't forget this guy, yes? Do you guys understand why that's there? The little dx dude? Do you understand why it's there?
No.
Isn't it like kind of the same thing as the integral symbol?
No. It leads to me putting in an integral, and then it makes sense because it's got the d piece for the integral. But here, watch this. If u is 2x squared, what is du dx? So what is it?
4x.
Multiply the dx up, whoop-de-doo. Yes? That's all. So if you don't put it there, you're inherently wrong. It's got to be there. It's got to be somewhere. It's got to be either on the bottom or over there. And what you just said, whoever just said that, is correct, because now if I write it like that, when I plug it in, it follows with the integral. I need integral d something. If I'm missing the d something, the symbol is not complete. It doesn't even make any sense. Okay, how we doing, sir? That's the kind of question I love to drill down to. Because if you go, I'll just do it because they said to, that makes a shaky foundation. I want you to really understand why the hell we put it there. Of course we put it there, because it should be down there. We just multiplied it up. Who cares? Now, how do you know when you have to use u sub when it's a more complicated integral than just integral of secant squared? It just goes right back to something. I'm going to try u sub that's more complicated. How do you know when u sub works? When there's a function in the integral whose derivative is in there also. Constants, I don't give a shit if I'm missing a constant. Because what do we need? What am I missing inside the integral to find du? What is du? 4x dx. Can I find all of that in the integral? How much of it can I find?
A quarter of it.
I can find x dx, yes? So what do I wish was in there, damn it? Jeff, why did you write it wrong? I wish there was a 4 in there. Can I just put a 4 there and go, you won't notice? I've had people try. If I, you won't even notice, even though it's you doing it, Jeff. It's probably true. If I multiply something by 4, how do I undo that? Okay, so as long as I multiply and divide by 4, I'm multiplying by 1. I can multiply everything in the universe by 1. So watch this. How much do I want to say here? Okay, I'm just going to be really blunt. I'm getting old, so I can be blunt. Who cares? It is really dumb to solve for dx. It is just an abomination, and I wish my colleagues would stop. Because that makes people feel as if they can do more integrals than they really can. Can you always solve for dx? Of course you can. You just divide by this shit, yes? Of course you can always solve for dx. Does that mean that u sub will always work? No. Why will this one work? Because what variable does du need? X to the first power. Do I have x to the first power? Yes. So instead, what's much better, and what actually hones a skill you need anyway, is balance. I need a 4 inside. Well, if I just write a 4 here, at the same time I better frickin' do this, do I still have the same problem I started with? Because you're not allowed to substitute your own reality when you don't like the one I gave you. And we didn't. 1/4 times 4x is still the same integral from the beginning. Are you guys with me? That wasn't hard. Yes? And it's much more, how do we say that? Clean. Yes?
You multiply it by 4, because you have 4x dx, you multiply it by 1/4.
To undo what I just did. So I kept the integral the same. I didn't make the problem a different problem. It's the same problem. Okay. So how can I start? Now the next level of u sub is, if I'm using u sub, I need to replace all my x related shit with u related shit. Everything's got to be replaced. If I have an x left over, I did something wrong. Can't go forward. 4x dx is 4x dx is du. I got a 1/4 integral. What's this going to be now? Cosine u. So let me see if you guys are with me on this. If I read this integral, it's 1/4 integral cosine stuff, derivative stuff. Do you guys see that? What if I read that one? It's 1/4 integral cosine stuff, derivative stuff. They're the same dumb integral. They're exactly the same integral. Just one of them shows me the structure clean, which is all I need. I just need the structure to be able to integrate, and then I can bring the details back. Just move the details out the way for a second, dear God. We'll bring them back at the end. So what u sub does is says that shit is really just this. Just kind of like collecting all the details together. What is the integral on cosine? Sine. Thank you. Remember, I can hear it. It's like learning how to drive stick and so you're going the wrong direction. So this would be 1/4 sine u plus c. If you circle that, you lose points. Why? Yeah, my question was about x. You better. And so if I said, "How's Frank doing?" and you said, "Bill's pretty good." What? So I have a question about x. You better freaking answer about x. 1/4 sine of 2x squared minus 5 plus c, blah, 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 blah. And if you have time, how do you check that? Take a derivative. All right, cool. Is everybody kind of with me? Everybody did use substitution in Calc 1, is that true? Is anyone? Well, okay. Got to be politically correct. There are certain colleges where they sometimes don't get that far. And then Calc 2, for me, I look like an asshole. I'm like, you should know it. And then I go, why would I know it? Okay. I don't know. Maybe some sister college does. I don't know. All right. Let's look at an example of u sub that's not quite what I said in the first place. The 90% of the thing won't work here. If you had to identify a piece of this that's stuck, what would you say? What part of this is stuck somewhere? It's fine. The x is stuck on the bottom. But I don't want to let u equal x, because then what's d? dx. And then the ln x, I got nothing for it. Yes? So what works 100% of the time? Let u equal the thing whose derivative is in there also. Yes? So if I let u equal ln x, what's du? Do I have a 1/x? Hell yeah, there you go. There you go. So 100% of the time, for u sub to work, whatever you let u equal, its derivative has to be in there also. That's it. That's what u sub needs. 90-something% of the time, the u is what's stuck. It's something stuck on the bottom, something stuck inside of a sign, something stuck somewhere. How are we doing so far? You guys all right? Okay. Where have I put? Have I not been using you? That's why I can't see shit. Oh my god. So if I let u equal ln x, du is 1/x, and just to make this really, really in your face, if I rewrite this like this, which I could do, I don't need to, but I just did it. This is du. This would be u. And then there. Okay, so much ass. Again, integral is stuff, derivative stuff. Integral stuff, derivative stuff. It's the same integral. And what's the integral of u? That's a deep question, Jeff. What's the integral of u?
E to the x?
No.
U.
No.
U squared over 2.
U squared over 2. There we go. Yes.
Oh.
And listen. Don't take it wrong when we're in the middle of like reviewing. This is still weird shit because you didn't use this much in Calc 1, did you? This was at the tail end, and then you almost immediately went and did disks and shells and weird shit. So I don't blame you for like not being 100% with you stuff. But it's just give yourself some grace for in the middle weird shit forgetting simple shit. Integral of u is u squared over 2. You know that. It was just kind of like hiding behind weird shit in your head. So this is u squared over 2. And of course, what do I have to do?
Back to the x.
Yeah, back to the x. I'm going to write it like this just because I'm weird. Don't matter how you write it. Okay. I like it. I like it a lot. Man, you got it before me, Michelle. Is that all right? You guys see the point? I wanted to make that point. One problem with a clean u that's stuck somewhere, and the other problem is u picked because its derivative is in there. That's what happens all the time. Okay. So, what we're about to get into, can somebody think about this problem for a moment? Can somebody identify what would make u sub work here if I would have put what where? What would make u sub work here?
Rating on one of the x's.
Not either one, only one. If I would have made this x squared. In fact, I kind of like what you just said because I want to, if it would have been this, if I let u equal x squared, what's du? Do I have an x in there? I have a cosine x. U sub wouldn't work on that either. If only I would have made the x inside a cosine here squared, u sub would have worked. So if straight integration won't work, and if u sub doesn't work, do we know anything else? So currently we're screwed. If you do know something, then you've heard some Calc 2, now keep it yourself. Okay. Are you guys kind of with me? I want to give us motivation about why chapter 7 is going to be chock-a-block full of different ways to integrate. Do you all appreciate that integration is useful yet? In Math 180, I'm hoping you saw a lot of examples work. In fact, here's the thing I want you to realize. I just told my Calc 1 students this yesterday. Math starts at calculus. Everything before that is getting ready for calculus. I'm not going to say that to a pre-calculus student, and that's all they need. That would be really mean. But if you're going into any STEM, for you, math started in Calc 1. Because once you know integration, it's freaking everywhere, even places you had no idea it was there. A lot of the stuff we do in algebra was built on the back of calculus. We just don't show you that. We just go, here's how you do it. And then later we go, oh yeah, I can show you why that works now. So it's all right. Integration is very important. I have an integral right now that, do you agree that looks very simple? It looks simple. If you don't think about it too much, there's just two things. It's just x and cosine x. That should be easy as shit. But right now, it's impossible for us to do. So I'm going to go through the derivation of the process we're going to use. And in the meantime, I'm going to remind myself, at about a little before 9, I want us to go on our little field trip. So it's not your job, but if it looks like I'm forgetting, maybe point it out if you think about it, yes?
Why is that impossible to solve?
What do you think I would do?
I don't know.
Good, there you go, okay. So I can't integrate each piece by itself because I couldn't even differentiate each piece by itself, yes? I would need to use product rule if it was a derivative question. So integration is always worse. I don't have product rule for integration. Integration is always trying to undo the derivative. Can you guys come up with the function whose derivative is this? Maybe that's the way I should say it. Think about it for a second. What function has a derivative x cosine x? If you really think about it for a moment, you'll go, oh yeah, he's right. It's freaking impossible. I don't know the function whose derivative is x cosine x. Are you kidding? I don't have that shit memorized. I've done this stupid integral many times. I didn't memorize it because it's easy to do. Well, right now it's impossible, but once you see the process, it has a nice flow to it. Are you guys thinking about that? It can't be x sine x, because that would be product rule. And there's not two terms there, yes? And the minute you go, it can't be that, you're like, it can't be x squared sine x, the product rule again. Do you guys start to see how I can't tease out where this came from? Because what's an integral always asking us? What function did I start with whose derivative is this? That's what an integral is really kind of like, one way to look at it is that. Is everybody with me? Okay. I love the question though, dear God. Don't hold back on this kind of question. So we're going to put a pin in this. We're going to have to come back to it because we don't know yet. I keep talking about product rule. Let's say that u is some function of x and v is some other function of x, yes? I'm going to use u and v just to make it quicker to write all the shit I'm about to write. So I don't have to write f of x, g of x, okay. So, if I write this, that's the product of two functions of x, yes? Can you guys help me figure out this guy's derivative? In fact, you guys take the derivative. I'll be right back.
This is f prime g plus g prime f, right? That's what he's.
That's what I was thinking.
V plus g.
All right, you guys done? So how do I do this? Yes.
F prime g plus.
No, don't give me the. Give it.
U prime v.
Yes, d by dx u. Oh,
Oh, u times v plus v prime u,
okay, so I got it.
right?
I'm gonna do it, I swear. Okay, there. You're saying primes I was throwing in.
Sorry.
You're good. I have now, we all know that u prime in general means d by dx. Do you guys understand now that prime notation sucks a bit because am I always taking the derivative with respect to x? So if I use prime notation, I'm kind of hiding what variable I'm taking the derivative with respect to. Yes? So this notation, even though it takes more to write, is superior because there's nothing hidden. I can see I'm taking the derivative with respect to x. You guys kind of with me? Are you okay?
You're such a better teacher than my last one. You're.
No. Don't do this. Don't do that to me. Okay. You're raising the bar. I can't do it. Now, watch this. This is so cool. Do you see how every single term has an over dx? So I could just multiply both sides by dx and just kill them. Is everybody cool with that?
No.
Okay. So then what am I left with? I'm left with, let me write this like that, yes? All right, now listen. I love this moment in a class because you're all sitting there like, so I paid this money to take this class just to watch this fool play with letters. Great. So right now that doesn't really mean much to us, yes? But can you follow where that came from? Okay. What's the integral dx? For this next step, I need us to understand some old stuff at a deeper level. What's integral dx? Don't overthink it. X plus c. What's integral dm? M plus c. What's integral d Jeff? Jeff plus c. Okay. So what's integral? If I take the integral of both sides, what's the integral of d uv? UV. Kick ass. Boom. Bam. Right? Okay. So this basically does that. And these two, I don't have a freaking clue what that shit is. So if you're sitting there thinking, what's he going to do with those? I'm just going to rewrite them because I have no idea what they are. So the last step here is I'm going to solve for one of the two integrals. In the grand scheme of things, it doesn't matter which one, but what we normally solve for is this one. So to solve for that one, I'm just going to subtract this one from both sides. Is that cool? You guys with me? So in terms of just manipulation of letters, did you follow all the steps I just did? There's a little bit of algebra, there's a lot of calculus. No? What happens? Where did I lose you? Can you tell me where I lost you or no?
UV equals integral DE plus.
Are you cool with integral d stuff is just stuff? That's what we just did, right? Integral dx is x.
You gotta come out.
Integral dm is m. Integral d Jeff is Jeff. So what's integral d this? This. And then I integrate both sides, of course, because whatever I do to one side, I have to do to the other one. So let me write our result up here. We got this. The integral of u times dv
Zoom out of it.
is uv minus the integral of v du. Great Jeff. Good job. Okay, now, if I bring back the integral we were just talking about. So what this statement says is if I have an integral in this form, I can rewrite it in this form. And my hope is that that integral is doable, whereas that integral was not. Do you see how there's a neat piece in here? My original integral has u dv, and this lets it switch. And then I'm kind of hoping, oh, please end up being a nice integral, and it happens a lot where it is a nice integral. So watch this. If I bring back our question, the one that was impossible for Calc 1 students to do. I need you to notice something. I need to identify how this is in that form. We get to pick two things then. And this is where it feels a little bit like USUP. But I have to pick two things now, not just one. I have to pick what I want it U to be, and I have to pick what I want dV to be. And the difference between this and USUP is whatever I pick U and whatever I pick dV, when I multiply them, it better be the original integral again, because that's the form I claimed it to be in. Somebody kind of with me so far. So if I have an integral where I have two things inside, I can make part of it U and the rest of it dV. And then this tells me where to kind of populate all that shit, and I'm hoping that second integral is either easier or possible in the first place, yes? All right, so how's this gonna work, Jeff? I don't know. Which one of these, like, I have two functions in here, yes? Mm-hmm. But one of them is gonna have this attached to it, because that would then be equal to dV. Which piece of that has a worse integral? I don't know if you guys are with me on this.
Cosine.
No.
X.
The integral of x grows in degree. That's not what I want. So in general, when I'm doing by parts, I want u. I try to let u equal the piece whose derivative starts to go. So if I have a polynomial piece, I'm going to let u equal that. Because the derivative of a polynomial is always better than the original polynomial. It's a lower degree. Yes? Integral?
Yes.
So what's two ways to look at an integral? Finding the area under a curve. So that's the first thing we talked about with integration, was finding the area. And then we connected it through the fundamental theorem of calculus. We connected it to the antiderivative. So an indefinite integral is asking for the antiderivative. A definite integral is asking for the area under that function between those two numbers. Cool. So this question is really just saying, hey man, what's the original function? Whose derivative is this thing? That's what we're trying to figure out. Yeah.
Can you repeat what you said about if we should do du or dv when we're integrating by parts? Like, how do we know which one to do?
Let's do this, and then I'll show some more examples to fully flesh that out. So I'm going to let u equal x. What's the other choice I have to make? And in fact, if I let u equal x, the other choice is not a choice now. What must dv be? Cosine x dx. If I take, I really want you guys, and again, please let this settle in. You're not supposed to suddenly understand this. Have we even done a problem yet? No. Okay, so try to let it settle into your bones. Just, I have to pick a u, and I have to pick a dv. So dv has to be this, so that u times dv will end up being this whole thing again. Now, what does this need to know? It needs to know u. Yay! It needs to know, it doesn't need to know dv. It needs to know v. Shit! It needs to know du. Shit! Okay, so can I get du?
Yeah.
What's du?
1.
No. 1 dx. Yes, you have to get really, really used to that. How many of you guys have to take Calc 3? Okay, I really need this. Even if you're not going to take Calc 3, you got to get used to the end. Calc 3 plays with that end shit a lot. So you need to get really used to that just being an automatic. It's got to be there. If you leave it out, you're screwed in Calc 3. In Calc 2, you're also screwed, sorry. Yeah, I'm sorry.
I was just going to say, why did x turn into dx if dx is a part of the dv portion?
No. Okay. These two came from the integral.
Yes.
Look at me, you ready? U is x squared. What's du?
2x.
dx. That's just what du is. I don't give a shit where you came from. When I get du, it has a dx on it. That dx didn't come from the integral. It's just what du ends up being.
I see.
So u equals x, du is 1 dx. That's just what it is. This dx came from the derivative. That dx came from the integral.
I see.
What do I have to do to this to get v? Yeah, dude. Integrate. What's the integral of cosine? Oh no. Sine. So I really want you to see this because I do remember when I was taught by parts and I hated it at first because you pick u and dv. You immediately figure out what du and v are. And now your little recipe just tells you where to put them. So if I use the recipe, and again, where'd this recipe come from? It came from frickin' Calc 1. All this shit is Calc 1. All of it's Calc 1. But I've never put it together like that, and that becomes Calc 2. So if I look at this, this equals uv. All right, what's u?
dx.
No, what's u? X, right? I'm just doing this recipe, yes? What's v? Minus integral v is sine x. What's du? dx. So what's the only thing I need to do that's left here to do? Yeah, what's the integral of sine? Good. Ain't none of us would have just thought that was the thing. I want everybody to check our answer. How would you check the answer? How do you check this answer? Take the derivative. Go ahead. Everybody take the derivative of this. And then we'll do more examples of by parts. Don't worry. Take the derivative of the answer we got. So this is extra, right? You don't always have to do this, but I just wanted to make you do it because I'm evil. So this is product rule, yes? Derivative of x is 1, derivative of sine is cosine, derivative of cosine is negative sine. What happens? Derivative of c is 0, sorry. What happens here? And what do I get? And so my answer is right because the derivative of this is that. And that's what this is trying to figure out. Do you guys start to see how ain't none of us going to be able to tease out what had to have been there to balance out to become this? I'm not going to be able to go, okay, if I put that there, then I need this there to kill that, but that leads this. If I do this process, it tells me the parts that have to be there so they cancel out the right parts to become what I had in the first place. Maybe. It is so beautiful. It's right now, I'm not going to use the word simple. But later when you look back on this, we used Calc 1 to develop this process. And then it just becomes a recipe. And here's the really cool thing. I'm stealing this from one of my colleagues, but I'm not a big believer in this kind of thing, but this is a little trippy to try to remember. But this integral is ultraviolet voodoo. Right? Ultraviolet voodoo. Is that how you spell voodoo? O-O? Not a word I spell a lot. Ultraviolet voodoo. That helps you kind of remember the form of it. That I don't care about too much. In general, I don't like mnemonic devices because they take us away from the idea. But this, I just never remember the form. All right, so yes.
Can you use any term as V, like DV and U, or is it?
All right, let's try another one.
like in-
Let's try another one. You ready?
Yeah.
Okay. Let me think. Yes, sir.
How do we know which one to make V and U and
Yeah, beautiful question. Let's build our way there. Let me see. Do I want to do? That won't really do it though. Yeah, let's do that. I love this problem. Okay. This one shows why earlier I hope I was pretty careful to say this. You almost always want to make u equal to the thing whose derivative you expect. So on that side, you might say I want to let u equal x squared. But whatever you pick dv to be, what do you have to do to it?
Take the derivative.
Whatever I let dv equal, how do I get v from that? I have to take the integral. So if I make u x squared, what's dv gotta be? Do you know what the integral of ln x is? It's too bad you're gonna to. Just to show off my grammar. You're gonna to.
Is it not 1 over x?
Say again?
Is it not 1 over x?
The derivative of ln is 1 over x. What's the integral of ln?
Isn't it e to the x?
Nope. No. I mean, what's integral of e to the x is e to the x. So the integral of natural log of x can't do that. We're gonna do integral natural log of x in a minute, yes? So if you're really curious now, just hold on. So I want you to take me down, I want you to go down the road I just went down. X squared looks like a good u. Jeff said, let u equal the polynomial most of the time. But if I do that, the thing I have to integrate is impossible to integrate. So screw that. What am I gonna let u equal then? ln x. So I want you to notice, let's do this right now. What are the candidates? Holy shit. What are the shit and a half candidates for u and dv? Let's go down a few. The candidates. U could be x squared, dv could be ln x dx. We already said that sucks. U could be x ln x, and dv could be x dx. Now, can everybody see why that's true?
Because you split it by x squared.
Yeah, any way you can split the parts of the integral up, as long as when you put them back together, you get the original integral, those are valid candidates. Do you start to see why we call it by parts? You take a part, and then the other part, and as long as the choices you made go back together to make the original integral, that's a valid candidate. Is it a valid way forward? I don't know yet. What's another way I could break this up?
Use natural log of x.
Yeah, use ln x, and then dv would be x squared dx. So see, every single one, the devil inside. No, Jeff. When I multiply these two, it becomes the original integral. That's how I know those are valid candidates. How do I see if they're valid ways forward? I try to integrate dv. Now that middle one is deceptive. dv is easy to integrate there, yes? But do you see how u's derivative would be kind of gross? And I've got to feed that back in. Which one of those looks the cleanest? Yeah. So let me write the problem again. Let's try it using this guy here. So if I let u equal ln x and dv be x squared dx, what's du? And what's v? Sorry, do it again. Yes. And you never have to put the plus c because that's going to happen at the end of the problem, right? This is the middle work. We don't have to put a plus c. Okay. This is where I can really hear the ears. I can see some smoke coming out the ears. Is because in the middle of an integral problem, you got to do a derivative, and then you have to do another integral. Is it? Your brain is trying to go between reverse and first gear, and it's sometimes the gears right. Now that I've identified all that, I just throw it back together. If after I throw it back together, I'm like, well, that integral is impossible, I go back and I try to pick a different way to break it up. So it is sometimes part of the process to pick incorrectly first. Picking incorrectly doesn't mean you don't know how to do it. You don't know the road's wrong until you walk down a little bit, right? Okay, sorry. Yes?
Isn't it 1/3 x cubed dx?
No. Why is this a dx? Because what did I do to get from here to here? What did I do? Derivative. What am I doing here? So let me write what I actually did.
Oh.
So of course when I integrate, both of these go away because it's one symbol, just two pieces to the symbol, yeah.
So when we're integrating by parts, we just start by selecting u and dv.
There you go. And your choice might end up being wrong, but very often there's no way to know that until you try to put it together. So it's fine if you choose wrong at first. Yes? Because some of these get really funky. They do. And you just have to play around with the different ways to break it up. But you should be used to this. I like to remind students, when you took pre-calc, you guys remember verifying trig identities? Where it said verify this bunch of trig crap equals this bunch of trig crap. So you had to try and make one side look like the other side. And sometimes you would pick the wrong identity. That's part of the process. It doesn't mean you don't know what you're doing. It means you know exactly what you're doing. You're just trying stuff out. So what is it that tells me you know what you're doing? You know you have to break it up. If you do that, right track. Even if the way you broke it up is wrong, you're on the right track. If it's wrong, go back, break it up a different way. Who cares? Okay. I just want to make sure you don't get on your own back. I see students that you get on your own back too much. Just get off of that back. You go, I don't know this shit yet. Leave me alone. Right? Identify what it is that tells you know what's going on. What tells you know what's going on? You know you got to break it up. Okay. If I put this stuff together now, let me put the rule down again. So my integral, is it real? What's uv? U is ln x. I'm going to put v in front just because. And then what's v again? And what's du? Was this the exact problem you were doing earlier? I can't remember his name. Somebody was showing me this one. I think so. Is everybody with me? So this is our question. We don't have to do shit with this. This is going to be our answer. But of course, what do I still have to do? Integrate this space. Yes? How do I integrate this? I get students that make so much out of this. You think this is another by parts problem. It could be. You could have a by parts that has multiple by parts steps. Yeah. I'll do an example like that then. Or I think I have one on the sheet. I'm going to make you guys do. What do I do in that interval?
Simplify.
Yeah, where are my students who took 180 with me? Before you attack it with calculus, simplify. Yes? Then I got less shit to worry about. So how do I simplify this? One thing I can do is I can take that 1/3 out, get that dumb thing out of the way. Stupid little number, get out of there. What's x cubed divided by x?
X squared.
There you go. And what's the integral of x squared?
1/3 x cubed.
Yeah, 1/3 x cubed times 1/3 is 1/9. Is that cool?
Yeah.
Done. Yay. How do I check it? Take the derivative. And if you take the derivative, you'll notice stuff cancel. That's why I end up at one term. So this process balances shit out for us. It's like this has got to be there to cancel this thing that would come from here, but there's no way we could have known that. Yes?
Where did 1/x go?
1/x. Oh, no, it didn't go anywhere. What's x cubed divided by x?
X squared? Oh.
Yeah, it's in there. It's like ragu. How do you guys feel so far? I mean, do you see how the process works? Now, you have to try problems out to really know how you think about it. So here, one side of this, I've got a few U-sub examples, just so you have it. And then the other side, I want you to work on. Oh, there is one thing I didn't say. I'll say it here after I do this out. Yeah. Otherwise, it might look like it's inside the ln. So we almost always put like trig functions, natural log functions at the end, so the other shit doesn't look like it's inside. Yeah. But I mean, mathematically, technically, either way is fine.
No, but I can see how that goes.
Yeah. We're trying to save ourselves from ourselves, basically.
Stop.
Yeah.
Good job.
Math is hard enough, and then we come in and make things worse. Thank you. All right, so one side is U sub, so you can have that for yourself if you need it.
That 1/9 came from you integrating x squared, and you still got 1/3.
Yeah, 1/3 times 1/3 x cubed is 1/9 x cubed. Is that cool? I will sometimes skip little steps like that. Don't let me off the hook. Just call me out if I do that. On the other side here, I've got the rule. I've got a more complicated example. Now, I want to point this out. You guys see the u and the dv I picked. Since cosine's integral is easy, I can let u equal the polynomial. Yes? Because then the du gets better. It's only the last problem we did, I couldn't let u equal x squared because that would leave ln that I don't know how to integrate. Yes? And notice part B here. Sorry. When I put this together, look at this integral right there. One red flag that very often points to an integral needing by parts is that it's a product inside. X times sine x. That's a product of two functions of x that might need by parts. Right? Now, if it was x times sine of x squared, u sub would work. So a product doesn't always mean by parts. Are you guys all with me? This is a silly, I think a lot of my colleagues call it liate. I like I late because it's kind of like sometimes I will be late to the 7:15 a.m. class. But this is the order in which you pick u. So the worst functions you have to make u equal to them. Do you guys remember the derivative of the inverse tangent or the arctangent of x? Anybody?
No.
1 over 1 plus x squared. Okay. Can you imagine trying to do the integral of the inverse tangent? Are you going to have to at some point? But can you imagine just trying to do that in 180? No, you can't do that shit. Yes. So if I have an inverse trig, damn straight I'm going to let u equal that shit. Because I can't integrate it. I can't let dv be that shit. I can't integrate it. Same thing with ln, or any log function. And then if I have algebraic functions, I might make them like polynomial functions, yes? And then if I have trig functions, I might decide to make u equal that. And then the last thing I'm going to make u equal is exponential functions, because exponential functions are easy as shit to integrate. Do you see how this, I could have done this in reverse for what to pick dv. So these are the order of like importance of what to try to make u equal. Are you guys understanding what that does for you? All right, so try out 1a. That's a classic by parts problem.
You say that if it's x sine x squared, that's easy.
Yes, real quick. There it is. Guys, real quick. If I did have the integral of x sine x squared, why is that easy? Why is that easy?
I don't know.
What's stuck? What function is stuck? If I let u equal x squared, what's du? 2x. I could put a 2 here, 1/2. It's just u sub, yes? It's just u sub. You guys see that?
I thought u sub was for derivatives, not integrals.
No, u sub is an integration method.
Alright.
Yes. Derivatives don't need an idea like u sub. They are just direct. Integration is always trying to undo differentiation, so we need some help. Yeah, okay.
Thank you.
You're welcome. So go ahead and try to do 1a. And whenever we do this kind of thing, it's not a quiz. You certainly could check in with people near you. I will have some like official group work for us to do, but whenever we do this kind of thing, you can certainly work with other people if you want to. If you don't trust the people around you, just hide your paper, get away from you. That's fine too. Just to make sure everyone's on the right track, what did you guys let U equal in part A? That's what you let U equal?
U equals X.
U equals X, yes. And then dV equals dVx. Is e to the x easy to integrate? Does x decrease in degree when you differentiate it? Yes. You guys understand? That's why if I have a polynomial piece, I almost always want to let U equal that shit, because then it's going to get better. Unless the other thing I can't integrate, then I have to reverse that. That's what we just did with the x squared ln x. I had to reverse that.
And is the EX of the DX attached? EX dx for dV?
Whatever you let dv equal, it has to pick up that dx piece.
And we integrate.
Otherwise, it can't be integrated.
Right.
I thought your isolate rules just didn't make U. Is e to the x not a log function?
No, e dx is an exponential function. Logs are inverses of e's. Yeah. That's why, like, at the top are a bunch of inverse functions, because inverse functions are always way weirder than the original function was. Yeah.
Thank you.
You're welcome. So that's what your first step should look like. Go ahead and try to set that up and finish it out. Finish it. So once you've got these, the rest of this is just recipe, right? So uv minus the integral of v du. And of course, the integral of e to the x is plus c. Yeah, we just saved the plus c for the end because I'm not going to put in all the little integrals in the meantime. Just collect them all at the end. Yes.
Can you simplify that as just x plus c?
Element.
Alright.
Sorry, buddy. It's because subtraction can't cancel multiplication.
Oh,
I have to divide by this for those to cancel.
I see.
Yeah. Let's go ahead and try to part B. Now look at part B. What do you definitely not want to let dv equal? So what's the only thing dv could be? What's the only other thing in there besides ln x?
Yeah.
Yes! That in itself sometimes is tricky. But yeah, dx is a part of the integral. So dv equals dx. Valid. Yes?
Why can't we just look at it and just say auto 1 over 1?
I was like, come on, come
I'm
on.
gonna say 1 over x.
I was like, if you said the right answer, I was like, show me.
Could we make
The
it?
student becomes a teacher. Huh?
Could we make that integral equivalent to y, and then?
Oh, you're trying to
exponentiate
no.
it?
Because you what's the only thing you could put into and out of an integral?
Constant.
Constants. You can't take a function inside and outside of an integral. I appreciate the attempt you're making. You're trying to do like logarithmic stuff, but
Yeah.
I can't, because effectively that would be raising the inside e to it and then bringing that e out.
Yeah.
You can't bring that
You can't
out.
bring it
You can't
out.
bring a function out. Yeah. Okay. So, what does u have to be then? Yeah, and dv has to be the other piece. So together, they recreate what was in there. All right, keep going.
I thought the dx turned into plus c.
Those, if you integrate, then there's a plus c. But like I said, we're not going to put a bunch of plus c's in the middle of our work. We're just going to put it at the end.
Yeah, I'm sorry.
The next thing you do is, what's the du equal? If u is ln x, what's du?
1 over x.
dx.
dx. I'm
Now
sorry.
integrate both sides of this.
Yeah, that was
And
my.
actually put an integral symbol. Yeah.
I thought that when you integrated dx,
Yeah, yeah.
the only thing that came that was left was the plus c.
No. What's the integral of dx? X. What's the derivative of x?
Like, 1.
So what's the interval of 1 dx? X. It's got to go back, right?
I see. My Calc 1 was such a shaky
Yeah.
that she said just consider the dx on the ends of things as the placeholder for the
Oh,
plus
God.
c.
Okay, so no. Oh God.
Yeah, so I
If I integrate this real quick, this will be x squared plus x. And I agree with you. You do put a plus c, but like this step, when I integrate this, I don't put a plus c because I'm going to put it at the end. Yeah.
I knew that it went in the end. That's why I was like, I don't know what's supposed to be there.
We just don't like put a bunch of plus c's in the middle. We just collect them all at the end. Yeah.
I've seen people sometimes with plus C's. I don't know where, but they subscript the plus C's, plus C1, plus C2.
Oh,
plus C3.
yeah. You could.
Yeah, yeah. I've
But
seen
why?
it, but I
Why
don't-
would we?
I don't remember where, but.
Yeah. Let's not do that.
I see.
Thank you. Sure. You just put u. Nice put u. So it should be an xl and x in front. uv minus, right? So uv is x times ln x. That should be right there. So this literally just says whatever u is, whatever v is, multiply them and write. And minus the integral. Right?
Just following this one.
Now why is that there?
I'm not sure.
What's it supposed to be? This.
That was supposed to be.
What's v? What's v? Just tell me. U. That's good. So there should be an x there. And what's du? Whatever it's dx. There. You literally fill in the rule with what those parts are. You told yourself what v was. You put it there for v.
Oh no, I just wrote it.
Okay.
I think it.
Yeah, it's okay. Yeah. The more, this one's nice because there's only two ways. You either let u equal dx or you let u equal ln.
Yeah,
Right?
but I think the thing is, like, you have to use zero part.
Yeah. Yeah.
He's making more Calc 1 than my Calc 1.
You don't have to make it so.
Yeah.
You just have to see if your choices need to.
I had a pretty good
Don't,
calculus.
you choose a different way.
Thank you.
Right? You don't try to
Like,
like,
she's not my teacher, but
you
it's
pick
like she
something
only
you
knew
start working, if you go that didn't
the
work, go
steps,
back and
but not
choose
the
a
why.
different way to break
So
it
she
down.
just wrote the steps and like the why, and she's like,
just to
because
make-
that's how it
Like
works.
that part,
You can actually explain the why behind something.
Yes.
you can continue. with-
Yes, 'cause the whole point of this is like I take an integral
You probably were to the math shit.
and have
She said
extra
just consider
terms,
that
but then I
dx
have a
the
integral
placeholder
here.
for plus c.
Yeah.
Yeah.
So I just would just mindlessly, alright, there's a dx that turns into plus c, doesn't matter that.
Yeah, don't. I really don't like.
Yeah. You've taught me more Calc 1 than my Calc 1 teacher.
Oh boy. I haven't said much. Oh, okay.
Oh boy, I haven't said much. Exactly.
What's the interval of dv? What's the interval of dx? There. So wherever you see v, put x. Same way that interval dv is v, interval dx is because, alright, I'll give you real now. There's a 1 here unrestricted. What's the interval of 1 dv? What's the interval of 1 dx? So you're right, we're not really integrating this, we're integrating exactly this one. Let's see. Yep, totally. Excellent. Yes, good. Where's your oh, that's the early one. Where's the where's your u and v choices? U equals ln x, du equals 1 over x. Yeah, okay, so.
Here's my final answer.
Oh, here. Right here. What's x times 1 over x?
1.
Yeah, so it should be 1 there.
Oh.
Yeah,
I
and
see.
then the interval becomes a little better. Okay, guys, let's take a look. So du is 1 over x dx, v is x. And just to really make this clear, there's a 1 here and a 1 there. So when I integrate, the integral of 1 d anything is just that thing. We're undoing that derivative. So then I get ultraviolet, voodoo. I'm literally just plugging that shit in into the right place. Now again, people just sort of forget. They make a big deal out of that integral. What is x times 1 over x? 1. You can simplify. Don't think you have to work with this shit. No, these die. Yay, they're dead. And what's the integral of 1 dx?
X dx.
The dx is gone. Dx is gone. Really quickly. I'm sorry, I took that away so quickly. I'm sorry. Does everybody see that?
Yes.
Okay, now watch this. What's the square root of 9?
3.
I've had students tell me this. What would you say to somebody who thought the square root of 9 equaled the square root of 3? What would you say? Do you see the mistake they made?
Yes.
What would you say to a student that said, hey man, square root of 9 is square root of 3, right? What would you say to them? Hopefully we go, what shit's wrong with you? I mean, it's your friend, maybe.
That the function's over.
There, perfect. The function did its job. Why would it still be there? Now, here's the trippy thing about integrals. That is not the integral symbol. This is the integral symbol. So what happens to a symbol once you've done what it wants you to do? Goes away. So what's the integral of 1 dx? X. These both go away because they did their job. It's the first function symbol that's like bookends. Like a square root puts stuff inside of it. The integral dx kind of like hugs the thing inside there. It's on both sides. So a function inside is like, this is awkward. But, once they've done their job, they go away, thank God. Are you guys all... That's a little tiny detail that I don't think teachers often say out loud. Yeah.
So when you take the integral of dx, does the d remove and it leaves you with the x? Like, our final answer is x plus c. Does that x come from the 1, or does that x come from the dx?
There are two ways to look at it. The best way right now to look at it is, what did I differentiate to get 1?
X.
X. And of course, with respect to x. If this is integral 1 dy, why? Because that's telling me with respect to what? Yes?
Yes.
Another way to look at this is, what does this actually mean? Doesn't this mean derivative of?
Yes.
So when I integrate it, don't these cancel?
Yeah.
That's the more dangerous way to look at it, though.
So
That's a little more dangerous because then you make some mistakes about that. This is the better way. What's the function that's inside 1? What's the opposite of the derivative, the x? Where would it have come from, x?
Yes.
That is the safer way to think about it.
All right.
Because this way leads to misunderstanding.
Because I see both ways. I thought the answer was x from the 1 times x from the dx gives you x squared.
Understood. But this is actually what's happening. This way you have to be careful about extending the idea. Okay, yeah.
I've always liked to think of it as x to the 0.
Oh yeah, totally. Yeah, there's no x's, so the antiderivative must have had an x. Because the derivative loses an x. Yeah. Okay, good. I like it. I like it a lot. All right, what do we think about this last dude? What's really exciting about this last guy?
Definitely.
Yes. So one little note before I make you try this on your own because I'm evil. When you do this, I know, but you start with a definite integral. This piece must be evaluated, and of course this is going to have to be evaluated. Do you guys see what I'm saying?
Yes.
So once you get that ultraviolet piece, the integration of it is done. You have to evaluate it between the endpoints. And of course this integral still has those endpoints. It's going to have to be evaluated also. You better end up with a number at the end. We know that. So go ahead and try to do 1C. Please feel free to work with other people if you want to.